Hi everyone, how are you all? In this video, I'm going to explain types of motions. In the previous video, I have explained rest in motion. So now we are going to discuss types of motions. So we have different types of motions are there. So in which here we have random motion, in which we have random motion. So I take a color, different color here. So this is a random motion and translational motion and rotational motion and oscillatory motion. So in the translatory motion we have subcategory, that is a rectilinear motion, curvilinear motion and circular motions. Okay, so translational motion, in which we have three categories, three types, three classifications. They are rectilinear, curvilinear and circular. So now we are going to discuss one by one. So in which here the first one, translatory motion. Translatory motion. Translatory motion. So what do you mean by translatory motion? So here if you take any body which is having mass m and also which is made up of different particles. For example, this is a body which is having n number of particles. Okay, and this body is moving. This is the body moving in this direction, and whenever the body which is moving from one place to other place here, so all the particles of a moving body which is moving in the direction of motion, that means here all the particles of a this body cover same distance. For example, this is the particle A and this is the particle B, this is the particle C. So for example, the body which is moving from A to B, so after 1 second this is the position of the block M. Okay, and A cover distance of, let us suppose this is M, B also cover the distance of M. So therefore we can say that this body is said to be in translatory motion. So simply we can write here, so all particles of a body, all particles of a body moving in the direction of motion, in the direction of motion, the direction of motion, the direction of motion, or all particles of a body, all particles of a body covers same distance in a given time or at the same time, in a given time in a given time in a given time. Okay, so E is called as translatory motion. Okay, so this is a definition of the translatory motion. Simply I can say that here. So I take one more slide here so that it is easy to understand here. I take one more slide here. Okay, so simply I can say that here, to understand the translatory motion, so I can take again a block of mass m. So this is the block M. So you know that here this is the body, system of body. So system of body, in the system it has so many particles are there. So this is a body which is having the so many particles, which is made with so many particles. That's why So if we take, this is the A particle, this is the C particle. So the body which is moving from A to B, so this is the position A and this is the position B, and this body A covers a distance of 1 meter and B also covers 1 meter in a given time, in the same time. So what are the time taken by the A particle to reach this place to this place here? The same time taken by the same time is taken by the B particle. Okay, so this is a definition of the translatory motions. Okay, the next motion is that here in that translatory motion, one more type of motion is that here, that is a rectilinear motion. Rectilinear motion. So what do you mean by rectilinear motions? So rectilinear. So rectilinear motion. Rectilinear motion. So here the body should be in translatory. A body, if a body in a translatory moves along a straight line, moves along a straight line, straight line, then that motion is called as a, then that motion is said to be, that motion is said to be that motion is said to be rectilinear motion. Rectilinear motion. It is also called as a straight line motion. Straight line. It is also called as straight line motion or linear motion or linear motion. So this is a definition of the rectilinear motion. For example, the body always moving along a straight line. Okay, now the body which is moving. So the body, if the body should be translatory, means here all the particles of the body moving in the direction of straight line. All the particles of the body moving in the direction of straight line. Therefore, that motion is called as a rectilinear motion. Rectilinear motion. Simple examples are, I can take simple examples here. The first example is that here a car is moving along a straight road. A car is moving along a straight road. So this is a one of the example straight road. So this is one of the example for rectilinear motion. Or a train is moving along a straight track. So this is a definition of the rectilinear motion and also example for the this type of motion. So next motion, that is called as a curvilinear. So curvilinear motion. So what is curvilinear motion? So again, in this case also a body should be translatory and moves along a curved path. Okay, if a body in a translatory and moves along curved path, then that is called as a curvilinear motion. Okay, so simple example here, a car follow the curved path. So there is a car is there which is follow the curved path. Therefore we can say that the motion of the car is here curvilinear. The best example is that here, if you throw, so this is my ground here, and if you throw a stone upward direction, we throw any object with an angle theta with respect to ground, the path always follow the curved path. This is also one of the example for the curvilinear motion. Okay, next one here, circular motion. Next here circular motion. So what do you mean by circular motion? So the particle which is follow the circular path. So the particle which follow the circular path about a fixed point, that is called as a circular path. So this is the particle P here which follows the circular path, about a fixed point. Circular path means the distance between the center point to circumference of the circle is same. Okay, this is a circular path. This is called as a circular path. Okay, next one, the rotational motion. Rotational. So rotational motion. Next is that here rotational motion. What is rotational motion means here? It is a system of. So this rotational motion is also circular motion, but here circular motion is applicable to single particle. Circular motion is applicable to single particle. We can consider only for single particle. But in case of rotational motion, so we take a system of particles. System of particles. We take a system of particles. That means here if we take a fan, here which is having the blades, first blade and second blade and third blade here. Okay, for example, if you take three particles on the first blade, this is the first blade, second blade and third blade, and on the first blade here we have three particles are there. They are A, B and C. Okay, so after once again here, so this A point comes here, that is we can take it as A1, and this is come after again once again which move to A2. So A1 move to A2, again moving like that. So A particle, one of first particle follow the path A to A1, A1 to A2, and now similarly the second particle follow the path, so B to B1, and so B1 to B2, B1 to B2 and B like that, B1 like that. Okay, and C, the C third particle also which follow the path C to C1, C1 to C2 and again C2 to C2. Means here all the particles in the system which follow the circular path, about a fixed point. So this is a fixed point is called the axis of rotation. This is the imaginary axis. So about this point here, about this axis here, all the particles are moving in a circular path about this fixed point. So this is called rotational motion. So here for analysis purpose only we can use a circular motion. So if you want to find out the speed of this system here, so we can take a single particle and find the speed of the single particle in circular motion here. So we can use it to find out the speed of all the particles. Okay, I hope that you understood the difference between the circular motion and the rotational motion. So go for the next one. So next motion here. Next here, vibrating motion. Vibrating motion means here, so always it's moving up and down. So whenever we make a vibration here, they're moving up and down. So this is called as a vibrating motion. Vibrating motions. Okay. Next motion is here oscillatory motion. So this is also called as one of the vibrating motion here. But here this is in this oscillating motion here, the length of the object does not change. But in the vibrating motion here, the length of the object may changes. Okay, but in this oscillatory motion here, the length of the object object does not change here. So in this case here, it is a to and fro motion. So to and fro motion about a fixed point, about a mean position. This is the mean position, starting position. Starting position means main position. About this main position. So the body which is making a to and fro motion, that is oscillations here. That type of motion is called as the oscillatory motion. So circular motion just we have discussed, rotation also discussed, curvilinear also we have discussed. Okay, next these are the types of motions, and go for the Next one here. Next here. Next concept here. Path and path length. Path and path length. So what is the path? What is the path means here? So if you take a point where a particle is placed. So after some time, so t equal to 0, this is the position of the particle A. After some time, after t equal to 10 seconds, 10 seconds, this is the position of the A. Position of the A. And after again 10 seconds here, this is the position of the position of the A. So it means here, if we join all these positions, so there is a formation of path. So this is called as a path here. So what is a path means here? So it is the line joining the successive positions. Successive means side by side position. Join all the successive positions of a particle in a motion is called as a path. Okay, so this is the first position and second position. These positions are called as successive positions. We join all successive positions here, so there it forms the path. This is called as a path. It is called as a path. Okay, next one. So if the path is straight line, if path is straight line, if path is a straight line, path is straight line, path is straight line, the type of motion is called as a straight line motion. Straight line motion. If path is curved, if the path is a curved path is curved, then the type of motion is called as a curvilinear motion. Curvilinear motion. Curvilinear motion. Same. If path is a circular, if path is a circular, path is circular, then the type of motion is called as a circular motion. Circular motion. Same. The path is a linear motion. That is linear. The motion is called as a linear motion. Okay. So this types of motion. According to the path, we can say types of motions. Okay. Next here. So path is a relative. Path is a relative. How can I say that path is a relative? For this here, so I take one of the example here. So if you take a Cartesian coordinate system, this is x and y here. Here there is a person who is traveling in a aeroplane, another person who is on the ground. Okay, so there is a person who is on the aeroplane. He dropped a stone, he dropped a object here, and so according to the person who is traveling in the aeroplane, the path of the stone is straight line. So according to the person who is traveling in the aeroplane, the path of that stone is a straight line. But according to the person who is on the ground here, the path of the stone is here. It follow the curved path. This is a D and E. It follow the ADC path. Okay. So actually, what will happen means here. So they feel. So he feel that here the path of he means here the person who is traveling in the aeroplane. He feel that the object is moving in straight line, but actually it is the path of the according to the person who is on the ground. The path of the stone is here, or object is here, ADE path. Okay, that means here observer to observer. So the path is changes. The shape of the path is changes. That's why path is a relative. So when a body is dropped from a moving aeroplane, the path of the body with respect to the pilot is a straight line, while its path with respect to the person on the ground is a parabola. Okay, I hope that you understood. Path is a relative. Path is relative. Okay, next path length. So just we have studied that path. So if you measure this path length, then that is called as a distance or path length. Path length is also called as a distance. Okay, path length is also called as a distance. Length of the path is called as a distance, and its SI unit is here meter, because here distance nothing but length. Then SI unit of length is here meter. Dimensional formula. What is dimensional formula? So any physical quantity that can be represented in terms of fundamental. So length is a fundamental. Length of dimension formula capital L. So or otherwise we can write here m power 0 L power 1 t power minus 1. Yes, it is a scalar quantity. It is a scalar means here it has only magnitude. It has only, what is a scalar? So it has only magnitude. Yes, only magnitude means here quantity homogeneity. Just simply we can understand that numerical value and its unit. Okay, how many times that unit, it is 7 into meter. So this is called as a uh, scalar quantity. So we need only scalar, does not need any direction. It does not need any direction, only magnitude. So if you know the magnitude of the distance here, we can use it to find out the distance of the length of the any object from the given location. Okay, the shape and length of the path are related. So just I said that here shape and the length of the path are related. So according to the person here, according to the person who is on the ground, just I said that here previous slide here, we go back to previous. According to the person who is on the ground here, the path is parabola, length is this much. According to the person who is traveling in the aeroplane, the path length is this one, the path is this one. Therefore path or path length both are relative. Okay, next. So now we do some problems here. The first problem is that a man walks 4 meters towards east. A man walks 4 meters towards east and 3 meters towards north. Okay, so whenever in the given problem he mentioned that direction, just to take the axis, x-axis and y-axis. This is a Cartesian coordinate system. The use of this Cartesian coordinate system is to locate the point. To understand the location of the point, we use this system, Cartesian coordinate system. So this is the point where two lines are intersect, two axes are intersect. That point is called as origin point. Always we can assume that always the body starts from origin. So we can say that the x-axis is always east direction, and negative x-axis, that is x dash, always we can take it as a west. So opposite of east is west here, and upside positive y-axis always indicate the north direction, opposite of north is the south. Okay, right. So now where I am, so that is center point, it is at the origin. Now so man walks, there is a person who is on the origin. Starting point is origin point. So a man walks 4 meters towards east. East means here he is going like that here. How much distance here? 4 meters. He traveled 4 meters distance. So he reached from O to A point. So after reaching 4 meters and then 3 meters towards north. So from he changed the direction towards north means here parallel to the y-axis. Parallel to the y-axis. So going from A to B with a distance of 3 meters. Then there he climbs a pole of 12 meters. So there is a pole is there at B point. The length of the pole is here 12 meters. The length of this pole is here 12 meters. So now he reached a C point. Therefore now you have to find out the total distance covered by the man. So to find total distance covered by the man here, we have to find out the total distance from the starting to ending. So he covered a 4 meter first and 3 meters second and 12 meters next year. Therefore the final distance is equal to, so distance is equal to, that is 4 meters and 3 meter plus 12 meter, that is 7 plus 12, that is 19 meters. My answer is that here 19 meters. Okay, so in this case to find out distance here, so you consider only magnitudes. You consider only magnitude from the starting point to ending point. Okay, next go for the next question here. The cyclist moves from O to D. So where is O? This is a O, this is a D. So that this is starting point, O is the starting point, D is the ending point. And go back to the question here. Along the path as shown, the distance covered by him is. So what is the distance covered by the cyclist? Okay, so just I said that just add all the distance from starting to ending. So from O to A 8 kilometers, A to B 4 kilometers, and B to C 4 kilometers, and C to D 1 kilometer. Therefore we add all the distances from O to D. 8 plus 4 12, 12 plus 4 16 16 plus sorry 8 plus 4 12 12 plus 4 16 16 plus 1 17 17 kilometers. Okay, 17 kilometers my answer. Okay, so next problem again. So it mentioned that direction here. Again take the Cartesian coordinate system or x-axis and y-axis. This is x-axis, negative x-axis, and y-axis, negative y-axis, and this is a this is the east, this is the west, this is the north, this is the south. Okay, and the body moves 6 meter towards north. So from starting is O, starting point towards north direction. This is a 8-meter distance covered by man body, and 8 meters, sorry, 6 meters. First starting is 6 meters here. Next from the north, and he moves towards east direction, means parallel to x-axis with a distance of 8 meters, and he reached the point. This is A point. He reached the point B point, and then after he 10 meters vertically upwards. So from this point here, going vertical upward with distance of 10 meters. Then find out the distance covered. Just I said that here. So we have to find out the distance from starting to ending. So 6 plus 8, 14, 14 plus 10, 24 meters. So in this way we can find out the distances. Okay, so to find out simply in the case of distance here, so no need to draw all this here. After understanding this concept here, if you want to find distance here, just directly we can add all the distances. So 6 plus 8, 18 plus 10, that is the 24, my answer. Okay, yes, next one here, last problem in this video. A particle moves in a circle of radius. So the particle is which is moving in circular path and which is having a radius. Radius means here it is the distance between the starting center to the circumference of the circle. Circumference means this is the boundary of the circle. So this is called as R. So center to the circumference R, center to the circumference R. Therefore it is the radius of the that circle. Radius means distance between the center point O to circumference of the circle. So and distance covered by the particle in half of its revolution. Now we have to find out the what is the distance covered by the particle for half revolution. Half means this is the complete revolution. First find what is the distance covered by the particle for complete revolutions. For example, this is my complete revolution. I can take this is a particle which is going like that and going like that, and follow this path here and ends at A point. So what is the length of this covered circular path? So we know that here from mathematics here, circumference. If we want to find total length here, circumference of the circle, circumference of circumference of circle formula is here 2 pi r. This is the total distance covered by the body for full revolution, for complete revolution. But we need for half revolutions. For half revolution, we can take a half of the that complete revolutions. 2 pi r by 2 would get cancelled. So pi r is my answer. This is for half revolution. My distance is here pi r. This is a C is the answer. Okay. So like this we can find out the problems and distance here. In the next class we will discuss some more physical quantity. And please I hope that you understood my lesson. If you understand my lesson, please share and like, subscribe, and thank you very much.